Hello, welcome back to the Geog 300 Geographical Data Analysis video series for WVU. Where we left off with the last batch of videos was looking at inferential statistics and the general process for that. Now we are moving into some more examples, more techniques to both illustrate this and start to give you the background of different techniques and the questions they can answer, so that when by the end of the semester you get presented with a situation where you're just told, here's the question I want answered, you know what technique, what tool to use to accomplish that. This week's topic is looking at categorical inference, or inference with categorical variables. This is one particular set of illustrations of something we may want to do, and that is find the relationship between two variables. A lot of inference is things like, is this variable related to or affecting that variable? It could be as simple as things like smoking causing lung cancer. It could be the effect of racial categories on income, the effect of, as we had seen before, mask mandates on COVID rates. What we're looking for right now is the relationship between a categorical variable and in the examples here, we're relating it to a continuous variable, interval or ratio. There are ways to look at categorical compared to another categorical variable, or categorical versus ordinal. We will not see those in this class, but they do exist. If you have the book, at least the ordinal one is in the book. We're looking here at interval of ratio, as we don't have all of the time in the world to cover everything, and that's what you're probably most likely to see and encounter in the real world, so to speak. So, to put this in and to review the inferential process framework, we have our general problem, our general question, and we want to then go and identify a null hypothesis, and thereby an alternative hypothesis as the opposite of that null. What we're setting up, the null hypothesis, is that there is no difference in the groups. So we're using the categorical or nominal variable to form groups, and we find the mean of each group of that continuous variable. Yes, this is reducing it. It's bringing in the ideas from descriptive statistics of summarizing and comparing that summary, instead of the, in a sense, the complete full distribution. The techniques in question actually do bring in the variance or standard deviation as well. But we're saying there's no difference among the means. Put another way, bringing in the idea of samples and populations, if we treat each group as its own sample, could those samples have come from the same population? And it would say they came from, so the null hypothesis would be, yes, they came from the same population. They are equivalent, the means are the same, there's, in a sense, no relationship between the two variables, or nothing interesting going on. The alternate hypothesis is that there is a difference. Once we have our null and alternate hypotheses set up, the next step, okay, find a test statistic. Convert that into our test. Thankfully, as I've said before, Excel handles the math for us in doing that conversion, but we need to make it happen. There are, in fact, two different tests. If we have two categories, there is a mask mandate or there is not a mask mandate. That becomes a t-test. If we have three or more categories, then we have to use something called ANOVA. Analysis of variance is what that stands for. And so if we're looking at the example I gave earlier in the video of income categories or income values broken down by race. African American, Caucasian, Hispanic, Asian. There are more than two categories, therefore we will need to use ANOVA instead for that situation. We have other steps in that inferential process. Running that test statistic. So finding the null distribution under the null hypothesis, comparing the actual value from our own data against that distribution under the null hypothesis, and getting a p-value from that, the probability that the data supports the null hypothesis, and therefore informing our conclusion. The next two videos we'll look at that in more detail. One on t-test, one on ANOVA. So, as always, if you have questions, please feel free to ask, to send emails, to ask during the class Zoom sessions, and have a good one. I'll see you at the next video.